parallelograms and triangles. Parallelograms we're going to start with. So the height of parallelogram is the distance between, is the perpendicular distance between one base to the other. This one base is what the other base is. The height is the distance, perpendicular distance between the two. We could choose this to be the base and this to be the base, but then we'd have to have the height be from there to there. And the area of the parallelogram, it's very similar to what a rectangle is. It's base times height, but in this case here, the height is not the measure of the outside bit here, the side here. It's going to be actually the distance between the base, between two of the parallel sides, the base here and the base here, and the height is in between. And one way to think about this is you're taking a chunk off and putting it on the side, turning it into a rectangle. So in this case here, it's going to be 10 centimeters squared is going to be the actual measure there of that parallelogram. So triangles, any side of a triangle can be the base of a triangle. The height of a triangle is the length of the perpendicular segment from a vertex to the opposite base, from this point here to the opposite base, from this point here to the opposite base. So that's why we have all these. These are all bases, and it would all come up with the same calculation. Just it would be choosing a different base measure. Now this is a more traditional triangle. We got the base here and the height here, and this is perpendicular here. This triangle is a little bit different. We got the base here, but we can't draw a perpendicular line that would meet the vertex up here. So we have to extend this out and then do it. This is going to be the height here, but this is still the base, not this whole thing, because this is extra space. We just need the height measure and we need to extend it out, but we still only count that as the base. So the area of a triangle is 1/2 times the base times the height, and here's why. You go ahead, take a triangle, duplicate it, then flip one over 180 degrees, and you've got a parallelogram. So it's just base times height, and then you half it because you only have half of that amount of space covered. For example, what we got here is if this here is a rectangle, and let's assume that these are rectangle, this here is a rectangle, I'll make that so. What we got here is, that's the one you're most familiar with, so it would just be 4 times 5 4 meters squared, 4 meters times 5 meters squared, 5 meters, so it would just be 20 meters squared is all it would be. So, and you do need to make sure to have that meters squared thing denoted. Here it's going to be 4 times 6, so it's going to be 24 meters squared. Now don't fall for it if there's something here on the outside, because that's not the height. And if we had something here, if it was over here, we had something 3 here, that would still, the height would be 2. So this one here, it's just going to be, well, it's just going to be like it is here. It's going to be 20 meters squared. So that's pretty easy. Now, one of my favorite foods is French fries. I don't have them very often, but I like them. So if we have French fries, sometimes look like parallelograms. If we wanted to figure out the area of one side of this French fry here, and it was 3 centimeters long and 1 centimeter high, all we do is 3 times 1. So that's just going to be a total of 3 centimeters. And remember, you got to have that squared part down. The last couple of things on triangles here. Again, here's a regular triangle. Remember, we got that formula, 1/2 base times height is equal to the area of a triangle. Just need to make sure you have the base and the height correct. So here it's going to be 2 meters times 2 meters. So it's going to be 4 meters. But we got to half that. So it's going to be 2 meters. Actually, it's 2 meters squared. For here, it's going to be 2 meters times 3 meters. You got to ignore that, because that's not a part of it. Remember what I told you about this. So this is just going to be a total of 2 times 3, which is 6 meters squared, and then we half that, so it's just going to be 3 meters squared, because this is 2 times 3. Now, one of my favorite chocolates is Toblerone. Now, Toblerone, I love that. Switzerland's finest chocolate. So here, if we wanted to figure out the area of one face of this, we would just go ahead and do 2 centimeters times 2 centimeters. And then we would half that. So it's going to be 4 centimeters squared divided by 2, so that's just going to be 2 centimeters squared is going to be the area of one face of that. So we're done.